Hi, good morning, Internet. This is Anupinder, and we are now in the sixth episode of our webinar series on mentoring sessions on C++. And today we are actually going to cover up this particular topic and which is relevant to the data structure, and we will be covering the concept regarding the dynamic memory allocations and the structures, the unions, and we also look at that how we can put up an alias corresponding to any built-in or user-defined data types. So quickly, if somebody can confirm me what about my audio, is it clear, because that is more important than my talking head. Love Kush says good morning Love Kush, how are you? Hope everyone is safe at their home. Okay, so let me start with the this session. I will be reviewing the previous episode first. So we have covered one of the concept regarding the templates, where we actually looked at how we can define the function templates without any type, and we can pass on the types at the runtime. Lavkush, thank you very much for confirming about the sound. Next is pointers. We have studied about that, what are the referencing and dereferencing operators, what are the different operations that can be done with the pointers. We have done certain arithmetic operations on that by using the unary operators as well as the arithmetic operators. Both of the things we have looked upon, where we can reference the different kind of memory location by incrementing or decrementing the pointer variable. Similarly, the arrays, which are kind of extension to the pointers, we actually discuss about how a one-dimensional array and how a two-dimensional array can work around, and how the processing can be done by using the pointer variables. Now, this is one of the most important data structure, linear data structure, which has been used in C++. Most of the time, you use it. And this is a static data structure. So static means that you once define the size of this particular data structure, you cannot change it. But there is a trick. We are going to look upon that trick. But if we are using by default any of the this data array, and if we are not using it by some dynamic memory allocation, it's a static kind of data structure, right? So that is what we have studied in our episode 5, and that was just a small review we have done. So if we look at the today's agenda, we are going to talk about the dynamic memory allocation, where we are going to discuss about the operators, then structures, and then unions. So I will be very quick with today's session. So in between, you have any queries, you can put in the comments. So when you talk about the dynamic memory allocation, this is what we have in terms of dynamic memory allocation. So unique and important attribution which has been provided within C++, and we can allocate the memory on the runtime basis. This is what is basically for the dynamic memory allocation process. So what operators are we using? We are using a new operator and a delete operator. So new is for the allocation and delete is for the releasing of the memory. Now, why we are having these two operators? So let's say I have a bunch of memory. When I talk about memory previously as well, I mentioned, but again, I'm mentioning that we are talking about a random access memory. That is a primary memory at hand, right? So let's say I have a couple of memory locations with me, right, for my particular programs, or let's say I have two variables, A and B, and certain memory is to be allocated to them in the real time. So let's say it requires 2 bytes and B requires somewhere around 4 bytes. Okay, so first 2 bytes will be allocated to the A by using a new operator, and next 4 bytes will be allocated to B. Now, if we look at this particular notation, what we are using for the memory, the total memory is now consumed by both of these variables. Now, in case if I want C variable to be allocated somewhere around 2 bytes, okay, so I need to have some set of memory available. Okay, and I'm considering that C will only ask for the memory when the operation of A is over, right? So we need to make this particular location released for that usage of C variable. So in that particular case, this delete is going to work out for me. So let's look at what is the basic syntax corresponding to it. So we define a pointer on the on the left hand side of the equality operator or assignment operator, and then we use new and the type. This is what we are considering corresponding to my particular set of example, or you can say simple syntax. Now this is only for one single type. Now one single type when I'm talking about, it could be int, it could be double, it could be float, right? Or it could be any built-in data type. Whereas, and which is going to store only single value. That is the prerequisite for this particular type of syntax. Now the other syntax is that we have a pointer which is to be used which is to be allocated with some memory of type provided and the number of elements. Now if you remember, when we were declaring the particular set of arrays, they were being declared by using the square brackets, right? So that is the same thing what we are doing here. So let's say if I wanted to take an example for this, both of these, so I can say int star ptr, I'm taking a pointer, equals to new int. Now this is the example for the first type. Whereas if I talk about the second type will be int, right, asterisk ptr equals to new int, and within the braces, square braces, what I'm going to have is 5. So that means 5 memory locations will be allocated to this particular pointer in the memory in the sequence, right? So 1 2 3 4 1 2 3 4 5 memories are available, starting from, let's say, some address value 1001, and that will go up to 1005. This is what we get for this particular pointer. Now because we wanted to delete these pointers, so this ptr, or let's say I'm giving this name as a ptr1. So for delete, we are going to have what we are going to have here is, let's say for delete, we are going to have delete and the name of the pointer ptr. This is the simplest example. Whereas if I am having a pointer, then int, delete, instead of this, I'm going to write it here, delete, and then braces I'm going to provide, and then ptr will be provided. So this actually indicates that this delete instruction is going to be working out for the array based memory allocation. So that is what we have in terms of our definitions, or in terms of our declarations of these dynamic memory allocation instructions. Now there is one important point which you should always keep in mind, that memory is a finite resource, right? It's a finite resource, and it may need a replenish. Okay, so every time we are allocating the memory, it is getting allocated from a memory heap. That means from the free set of locations, which has a limit. So allocation may fail as well, leading to an error, which is from the bad alloc error, right? This is the error which may be generated at the time of runtime, because we are asking the memory at runtime. So bad alloc will be the error or exception which is going to be printed, and which can be avoided by using a no throw keyword. Now how we are going to utilize this particular part, let me show you the code corresponding to this. So this is a sample code which is available on c++.com. You can go through the simple code as well in your own time. So what we are using here is, because we are using a new operator, so we need to have the new preprocessor statement to be included. That means the header is required to be included in this particular program. So this is important. So within the main method, we have 2 integer variables, 1 pointer variable. So what we are going to try with this particular set of program is, we are going to ask the user that tell me how much memory allocation requirements do you want to be allocated. So that means we are going to talk about this particular set of examples. So if we understand this example, we are able to understand this as well. So we are going to ask the user that, okay, tell us what is your requirement for the number of location that you want to put, and as per that we are going to have our allocation. So how the allocation is done, because we know this is a pointer variable, and that pointer variable is equated with the new, and the no throw will be put over here. So if you want that, in case of bad alloc of exception, the program should not terminate. In that case, you can put a no throw here. Otherwise, I'm going to put a simple instruction of that. Okay, how many particular number of uh, locations do I need to give, and that is corresponding to that particular value that user is going to input. Now, this is what is a trick I was talking about with respect to the array. When we are declaring array, we have to provide the number along with that particular part. But here we can do it by simply putting a variable name inside the square brackets. We need not to give any constant at this particular place. So that is what we have correspondingly for that particular purpose. So let me run this program for you first, so that you should be able to appreciate the working of this particular program. So let me do the build and compile. So it is going to ask me how many numbers you would like to type in. So I said two numbers I would like to type in, 5 and 8. So these were the numbers which we have entered. So that means this instruction, how many numbers would you like to type, is being asked from the user, that how many numbers do you want to allocate in terms of integer memory locations to a particular pointer. So that is what we are considering. So if you have gone through my previous episode, we have actually studied about the pointers in very much detail, and we spoke about that how the pointer is being helping out in array traversal. So that is what is being done here. P and in square brackets n is provided, where the n is ranging between 0 to I. So I'm going to give a large number for I, because I know it's an integer value which is there. So that means I can give somewhere around 32,000, right? It's a signed number basically. So if you remember how we define the signed and unsigned, it's a signed number because unsigned is not being specified here. So I can give the value of I up to 32,000 something. I think somewhere around 767, right? So 32. I'm going to put 500. So these are the number of integers memory location I'm going to ask to the system. So that means this has been acceptable right now. 32,500 locations can be provided, and I need to enter all these numbers now. So this is what is there in terms of your memory allocation part. So memory has been already been allocated to the pointer. And the loop is going to work for 32,500 locations, and that is what has been working around. So I've given 32,500, and it is going to have an infinite numbers corresponding. So I'm just going to close this program, just stopping this, and this time I am going to change this integer to long value. Right, so I'm going to give it a long, and then I'm going to give it more higher value. Let's see how much memory it is going to allocate, because I have around 16 GB RAM, and among that somewhere around if I show you my system's performance, so somewhere around 7 GB, 7.4 GB is utilized. So let me see how much we can utilize from this particular part. So F9 again, and we are here. It is going to tell us that how much values can we put. So 400000 plus. Okay, terminated, called after throwing an instance of bad array new length. So this is what we are going to get in terms of our maximum memory allocations that can be done in terms of the particular integer. So if you multiply this this number, I'm not sure how much zeros I have entered. So somewhere around 4 and 9 zeros I have entered. So if we multiply this number by 4 bytes, because integer is basically of the particular 4 bytes here. So 4 into this number, that is the total number of memory we are going to allocate during the runtime, which could not happen, right? So maybe if I change this number to long, hopefully it should work for you again. So long is not available because the type is not matching with the pointer. I'm going to run it again. Let me check if I can have that particular memory available. Previously, because we had, okay, again we had this bad array new length. So that means this is what we cannot allocate in terms of our particular memory. So this is how you can actually link about the particular part, that how the memory allocations are being done at the runtime. So if I put this particular new throw here, right, then let's see what exactly happens. Now we are trying to catch that particular exception. So I'm running this particular program again. So let me have the same number. Okay, so this is not the bad allocation part. Let me run that again. So maybe I put some value over here. Okay, so it is going to have more than that. So that is the limit. Again, anyhow, I believe I am able to convey the point that these particular set of memories are only applicable to be allocated if they are available on the real-time primary memory, which are available for the execution process. So that is what we get in terms of our allocation of the dynamic memory. And in case if we wanted to delete all the pointers that are being provided for that particular memory, we can do that as well by using this delete square brackets, which are empty right now, and p. So that means all the memory which are being allocated to this p pointer, that will be released correspondingly, right? So that is what you can have in terms of your dynamic memory allocation. So new and delete operators are the one which are being utilized corresponding to this particular memory allocation and memory releasing, right? Now, next thing which comes in the picture is the data structures, and within the data structure, we have already studied the linear data structure. That is the array, and is the most frequently used data structure within the C++ as well as C language, because it allows you to have a multiple values in one under one single identifier name. So similarly, data structure, which similarly the structures is also allowing you to have multiple set of datas under one single identifier, but it also, along with that, it also allows you to have more than one data element, right? Because if you talk about array, either you can declare it as integer, character, or double or float or something like that, whereas structure allows you to have multiple type of data element which are actually grouped together under one single identifier name, and the data elements are known as the members that are being utilized. So this is what we have in terms of our data elements inside the data structure name as structured. So any member which has been defined inside the structure can be accessible by the dot operator or by the pointer operator. So it's up to us how we are actually going to utilize it. So this is the basic syntax for this particular structure. It says the struct, which is a keyword which is being used. This is the name of the struct, and then curly braces. Within the curly braces, you define the member type and the member variable, right? So I can simply say if I wanted to store the value of a student, I know there could be a number of students inside a class. So what I can do is I can define a struct, and I can write a student, and that student can have, let's say, int roll number, and then that student can have some kind of let's say class. I can say integer class, and maybe character section. So it could be A, B, C, or whatever, right? And then my curly braces are being closed, and corresponding to, if you say, it says object name, so I can say, let's say Arun. I'm taking a hypothetical name Arun, and this is the object which has been created, and then semicolon. This particular part is optional. If you want to define the object immediately, you can define it immediately. If you want that it should be defined afterwards, you can define it afterwards. So let's go and look at the particular example here. So let me copy this for quick outline structure. So I'm writing this as maybe struct structures. Okay, so I saved it as C, which is not going to be helpful for me. I'm going to save it as structures CPP structures 1. Okay, so now what I'm going to do is I'm going to declare the structure inside the main. So maybe I can do it inside the main, I can do it outside the main. So what I'm going to do is I'm going to do it outside the main. So struct student, and curly braces are started. I said that int roll number, right? Int class, stud class, and then char section. Okay, so this is what I have defined. Now there are two ways: either I write the object here directly, that is Arun, or I simply define it as a variable. Now this is more or less a user defined type which has been declared at the top, and I can simply refer to as student equals to or student Arun, and that's it. And then what I can do is C out, enter the roll number, right, and C in. What I'm going to have is I'm going to have Arun dot my class. Sorry, it's a roll number, right? One thing is this, that Arun roll number is being added, and then Arun's class is to be added, and that class is stud class. That is what is the variable name we have given, and then we have section. We can have a section over here. So this is how we are referring to the structure data student structures data members by using a dot operator. So without dot you cannot access them. Similarly, if you want to print all the values, so I can do that. The cout values entered for the student are, maybe I should put endl here, here as well as here, and then cout roll number is being provided by Arun dot roll number, right? Then the class is defined by Arun dot stud class. I have it stud class only, yeah, stud class. And then at last, what I'm going to have is I'm going to have a section, right? And that section is again Arun dot section, and then we put endl here, and things are done. So if I've done everything right, it will be executing. Okay, so it says token is not right. Which line? 24. Cout. Expected primary expression before token. Cout. Oh, so I've actually added two extraction operators. So enter the roll number it is asking. So I say roll number 1, class number is, let's say, 10th, and enter the section, that is A. So this is how it has been provided in terms of your particular one single student. Now, if I wanted to have multiple students for this particular class, what I'm going to have is, like, generally what we are considered to do by using a programming language is creating the project, and that project is going to solve a particular kind of problem. So if you wanted to have some kind of particular array to be declared corresponding to your structure, that is what you are supposed to define into this. So we can see how we can do it for the students. So let me take you to the examples itself first. So if you look at this particular part, I again took the set of examples from different from C++.com itself. You can go through the set of examples which are there for the structure. So let me show you how we can do the student uh, you know, database to be created for, let's say, 10 students, right? So if I say I'm creating a student Arun, right, I'm providing a pointer corresponding to it, and then I'm also going to ask a user that, okay, tell me cout tell me how many students are to be stored, right? So this is similar to what we did in our previous examples. So I'm going to give the cin, and this cin is int count for the students. So count is going to be there for me. Okay, so I'm going to declare a particular pointer corresponding to this particular structure, right? Maybe I can also give it as a null, right? Null pointer, or maybe I can define it as a void pointer too. And if you look at this particular part, how we are doing it by using a new and whatever the type and whatever the memory location, memory addresses that we wanted to give for. So this is also a way, and static is also a way. So let's say if I'm trying to have this, I can utilize this particular part as well. So it's up to us how we wanted to define this particular structure. So I'm going to have a run or maybe a database of student I'm going to have. So new students, how many students do I need to give? Let's say that is based on the count. So let me first run it to check if the particular declaration is okay. Okay, so Arun is supposed to be declared. Maybe I am going to do a multi-line comment first. Okay, so I can have a particular number of users or students to be entered into the system, right? So this is where I'm going to store. So let's say I'm going to have 2 users to be added. Now further I need to go for a particular loop, right? Here what I'm going to do is I'm going to do a for, and that for is going to have an int I equals to starting from 0, because we know arrays are going to start as an index of 0. I less than count, because we are going to have 1 less than I plus plus, and within this. Now what we are supposed to write here. So if I take you to the other part, so you can see what exactly has been done here. So when we are defining a particular pointer to a particular structure, what we are going to have is we are going to have a address for that particular structure, and then if I wanted to have the utilization of their member variables, then I have to use this particular set of operator, right? That is the pointer operator I have to use. So let me give it a try here, how we can utilize. So I'm going to have a database, right? Here we were using p. Yeah. So here database, because we are using a pointer first, so I'm going to use a I, and then if I wanted to have a direct access to the roll number, I'm just going to check this out first for the syntax, and then I'm going to put a cin correspondingly, right? So let me check, is it working? Struct student has no member. Okay, so it's not roll, it's a roll number. Great. Yeah, so I'm going to have for 2, first is 6 and second is 8, and done. Okay, right. So here I'm going to give it a neat touch now. Enter out, enter the values of the student number count plus 1. Okay. Now cin cout, or maybe I just simply copy these things. Enter the name and then enter these numbers. So instead of this particular part, I'm going to have an pointer of an array that is with the name of the database, and then one by one I'm going to have the entry correspondingly for my particular set of things. And same particular for loop can be used for displaying the value of all those particular set of students j, and here I'm going to have a, instead of these sections, I'm going to have a cout. So this is more or less a first entering a database and then printing that particular database correspondingly. So I'm going to use a database, and then within array we are going to have this j, and here again j, here again this, right? So we have made certain small changes. Value entered for the student number, I'm going to add that particular number count plus 1, right? And then just to have some neat printing, I'm going to have this. Okay, so let's check our logic is correct or not. So here what we are going to have is, let's say I'm going to enter number for 2. For student number 3, enter the roll number. So let's say I'm entering roll number 1, class is 10th and section is A. Enter the value for another user, roll number 1, class number 10th and section B. So this is what has been provided in terms of your particular set of users. Now why this 3 is printing here? Because the number of users, the total count of users which I've asked for from the particular input point, I've actually tried to print that. Instead of this, I had to actually do the printing of I plus 1 here, because the index started from the 0, and the number of the student which I have to put is what is the count which is in the current consideration. So this is what you have in terms of your data structure management. So let me do this printing again for you, so that this should be more clear. So I'm just going to put the new line in the front over here, and new line in the front over here, so that some more clarity we can get. So here, if you see how many students I wanted to enter, I am going to enter for the student 3 students. So roll number is 1, class is 10th and section is A. Roll number 2, class is 10th again, section A. Roll number 3, class is 10th and section A. So this is what you get. Value entered for the student 1 is this, value entered for the student 2 is this, value entered for the student 3 is this. So if you want, you can actually do the calculation corresponding to one more part. Let's say student secured how much marks, right? So let's say double is being used for the marks, let's say maths marks, right? And this math marks can be also asked for the entry purpose, right? So enter the marks for this. Okay, let's say I'm going to do math marks, and here I'm going to ask for the maths marks as well. So that's an out. That's just a printing part. And finally, what we can do is we can have this printing over here as well. So we do a copy paste, and within this we are saying maths marks are maths marks, right? And you can also implement a particular algorithm where you can check that, okay, which student has scored higher and which student has scored lower. So here, if we are entering the marks for that, so maybe I'm asking for two users value, roll number 1 and class is 10th and section is, let's say, B this time. Roll number 2, class is 10th. Oh, marks I entered for the mathematics is 2 here, because that is also supposed to put. Now the roll number is 10, class is 10th again, section is B, and the marks is 20. So this is what you get in terms of your printing corresponding to the user entry. So in this way you can actually define a program for doing certain kind of calculation of the marks, or certain type of let's say percentage calculation of the particular student record, and so on, maybe fee management and all that stuff. So till the time this program is in running, that particular memory will be utilized, and the structure can allow you to have these bunch of members to have a single identifier for containing that particular record, right? So it's more or less record keeping for each individual user. So this is what you get in terms of your structures, that how you can have a simplest structure where you define a structure's name and their member variables and their objects immediately, or maybe you define a structure and then you create their objects by referring to the name of that particular structure and creating the objects. Now I'm specifically referring the objects, so that means we are going towards the object oriented programming, a step-by-step mode, because structure is the one whose concept has been extended to create the classes, because this structure only contains the member variables, whereas class also contains your function members as well. Similarly, we can have another set of structure which is being defined, and there is a pointer which we can define corresponding to that particular structure, and that pointer can also be either pointing to this particular value or particular another object, or maybe it can be utilized for dynamic memory allocations as well. Now there is another concept which we can have, and that concept is a nested structures. Right, nested structures, what they allow you to have, they allow you to have a particular structure used inside another structure. Okay, so here if I take the same example again, what you can do is you can do the marks as well. So I'm creating a struct marks, and this marks is for, let's say, int English, right, int maths, and int science. Simply I write science. So instead of marks, I'm going to use here. Now I'm going to use this particular structure which I have defined above, marks, and then stud subject marks, right? So in this way I can do that particular stuff. So if we check here, so what changes do I need to make is enter the English marks, right? And then instead of using the math marks directly, I'm using a marks, and then by using another dot operator, and I'm going to have a English, right? So if you see what's the variable name we have defined inside this English, right? So this is how I'm going to have the value. So double dots are being utilized here. So it's in the same manner, if I go for the next particular subject, that is enter the marks for math. So I'm going to have a maths here, and for the science, I'm going to have a sign here, and I'm going to put as science, right? So similarly, for what I have to do for printing, I have to do it for the printing of this particular section. So maybe section is done, and then we put endl here, and C out. In the next line, I am putting it C out. Marks are, let's say we are putting as English, right? And then for English, we are putting marks dot English, right? And then we can have more C outs. So instead of English, I'm going to put another S, that is maths, marks dot maths. And then finally what we have is, finally we have for science, we are going to have CI here. Okay, so let me check the compilation. Okay, it says the marks, no member named marks is being defined. Okay, so marks is here, and that marks is being defined inside this. The structure has no member marks. Okay, so how do we use it? We use it by and Charlie, and then if I wanted to have the, okay, so this is same we have used. Subject marks. Okay, so this was defined. Stud subject marks is supposed to be used here because that was the object I defined. I'm very sorry because I need to also keep the time in my mind because we have to finish our session by 12. So that's why I think I missed that particular part. So if I run this particular thing, you will be able to have, okay, see the operator, it is saying a roll number. The operator unable to find the string literal operator section. Which string literal it is asking for? With constant character. Okay, so in this particular line, it is showing me a particular error. All right, so this was the error which I made. It should run. No, it will not, because I have been copying and pasting this particular thing. So this is how, when we are doing it quickly, the errors could occur in our code, and the syntax errors may arise while compiling. So how many students? 2 students. Enter the roll number. So let's say roll number 1, class is 10th, section is A. Enter the English marks, that is 20, 30, and 30. Another student, roll number 2, class 10, section A, and I can have the marks which are, let's say, 50, 60, and 60, right? So second student has the higher marks, and the first student has the lower marks. So this is what you can create a database corresponding to your own users, right? So this is a typical example what can be utilized for the structure. It's not only this, you can do it for the products, you can do it for, let's say, customers, you can do it for let's say any kind of inventory. So all that stuff you can do, and in case if you want to do the calculation on these numbers, that can also be done. The only thing is that you have to devise the algorithm and put a logic inside this particular code. So this is how we can actually work around our C++ code to create the set of real time data sets by using the structured data structure. Okay, so this is what we have. Now another that we get in terms of the data structure, that's a union. This union is again the syntax is again is of type structure. The only difference is instead of struct, you are writing union, you are typing in a name, and then you can have a member variable, and then you can define an object. Now, this is a typical example we can have. Now, look at this particular example. This is of 1 byte requirement in the memory. This is of 4 byte, and this is again of 4 bytes. So maximum that we have is a 4 byte in terms of all these member variables. Now, union and structure, the major difference, again, a placement related question, placement interview related question, that the size of the union which it can occupy is the maximum size which is being asked by a member variable, right? So character is the smallest, float is the maximum. If it could have been double, so it might have been 8 bytes in case of double variable, right? So if we have double variable, then 8 byte would be the maximum memory allocation which is going to be given to this particular object of my type, right? Now that is one major difference. So union will have the size equal to the variable with the largest memory allocation, right? The location is shared so that so at one point of time only one variable value can be stored. So this is another example for you. So another difference for you that among the structure. So structure is going to have the complete memory allocation. So that means if we are talking about this 4 byte and 8 byte, right? So total requirement is 12 byte and this will be allocated. Whereas if I talk about this particular union, only the maximum 4 bytes will be allocated. And this 4 bytes is going to contain either the f variable value, I variable value, or c variable value. It's not like that you can store all the variables. Every time you replace the value of that particular variable, let's say this is the object I've created for this particular union. So my types dot c equals to a. So that means the memory is going to have the value a to be stored at this particular location, which is given for the my type. If I do in the next line my types dot I equals to 20, then this will be replaced by 20. And if I do my types, okay, so if I do my type, I need to do it again. If I do it for my type dot f, that is equals to 40, so that means this value will be replaced to 40. So you can only have one single value per variable in this particular corresponding union definition. So this is a major difference in structure and union. A lot of time this question has been asked in the interviews. There is another thing which we can utilize for reducing the length of the code, right? And that is either by using the type def or using keyword. Now what we are trying to do is we are trying to have a alias. So like if I wanted to have a value which is unsigned, so generally what I have to do is I have to define unsigned int a equals to 5. Let's say this is what I have. And in case if I wanted to have constant, so constant is also going to have been added to this. So this is a quite lengthy instruction. What if I do that type def, right? Type def constant unsigned int, and then by putting up a space, I'm going to have let's say CUI. Every individual word is going to define the first letter of the keyword. So CUI. So next time whenever I wanted to declare this particular statement and initialize the value, so I can simply see CUI a equals to 5. Now look at what is the length of this particular instruction comparison to the previous one, right? So this is what you can do. This is more or less programmer kind of thing, that you define the alias or short name to the set of built-in variable combinations, variable keyword combinations, data type combination, not variable combination. So data type combinations, and then you can utilize them as a data type itself with the declaration of that particular variable identifier. So you can see different kind of examples over here what we are using. So type def unsigned int is being displayed by word, whereas this type def char, this is going to be used for the pchar and so on. Okay. So same thing, you can see my char, another char, and this particular data type has been used here. Word has been used here. Pchar is being used for this, and field is used for this particular part. So that means whenever the field is used for the name, the array with the 50 character size is going to define for this particular name part. Okay. On the similar note, like we are using the type def, we can also use the using. Now using allows us to have a equality operator. Now this gives a more clarity in terms of in terms of the instruction definition for the alias. So like if we are doing this, we can do it as using. I'm writing this instruction in terms of using. So using, let's say CUI equals to constant unsigned int, right? This is what I'm going to have. So that means the CUI can now be declared, can now be used to declare this particular variable. They both work in the same way. Their notations are different, and using is more utilized in C++ because of the performance meters as well. So we can have a clear notations here with the using in comparison to type def. Type def could be a little bit of confusing, but here using can give you a better understanding in terms of your particular definition. So if you want to see an example, we can I can show you in just a minute, 1 minute. So if I use this as using CUI equals to constant unsigned int, right? So then I can have CUI a equals to 5, and this can be printed anywhere, wherever you want. If I compile this program, you can see it is compiled and can be utilized anywhere, right? So I can also ask for the input to that particular variable. So I can ask for the variable input. So maybe I can using or instead of that, I can use CUI for declaring this count as well, right? So I can do this run part. Okay, CUI count error, no match for the operator. Okay, so that means CUI can only be used for the particular constant part. So CUI ABC equals to 5, and that can be printed wherever it is being required. So value of alias based identifier is ABC, right? So that is what we get, and we can utilize this, and the build process is done. You can see value of the alias based identifier is 5. So that means we can have a definition for this, and then it is going to ask me for the further student count. So this is how you can actually utilize all these set of alias based thing, and things can work in a manner of making the code shorter and easy to understand. So this is what we have for today's particular webinar. If you have any questions, you can type in the comment section or in the live chat section. We can have that conversation. The floor is open for the questions. So I'll wait for 2 minutes for your entry in the entry of questions in this comment section or the chat section. Now, in case if you are looking for any kind of help in programming language like Python, Java, C++, or you're looking for help in database or machine learning, please feel free to connect with me on hello@superwits.com. It's been scrolling at the bottom of the screen. You can contact me on this particular email address with your detailed requirement. Apart from this, we also run a particular Telegram channel, which is available on, you can join this Telegram channel by using t.me/Superwits Academy link. And we regularly post our updates over there. And we can have a particular set of polls as well, that what could be the next series that we can run corresponding to your particular requirement. Like we are running this mentoring sessions on C++ webinar series, which is of 10 episodes. We can run another series as well based on your request. So you can join our Telegram channel on this particular web address, which has been scrolling at the bottom of this particular screen, right? That is t.me/Superwits Academy is the link. Apart from this, you can follow me on the Twitter. My handle is @Anupinder. You can email me at hello@superwits.com with your requirements. And also, the most important part, if you want to have updates, regular updates from our particular channel, you can simply subscribe to YouTube channel, and also click on the bell icons to get the notification for any new webinar which has been scheduled, or any particular video. So this is it for today's session. I think there are no questions. There is nothing in the comment section. So I believe that you have no queries for this topic. So thank you very much for joining in. See you on Monday in episode 7, where we are going to have more detailed discussion with respect to the classes. So thank you very much for joining in.